So this is part 2 of worksheet 10L. Remember, we're trying to prove that this is a rhombus. Okay, so here's 30 degrees as well. So what we do note now is that AB is equal to BC. Okay, why? So sides opposite equal angles, as well as this length will be equal to that length, which is AD has to be equal to DC. Sides opposite equal angles. Okay, so for the vertex angle to be intersected by the, or bisected by the diagonal, can be one of two shapes. Okay, can either be a kite, a rhombus, or a square. Square is completely out. The kite, the adjacent sides on either side of this diagonal should have been equal. So this is enough to prove that it's a rhombus. So you can conclude, therefore, ABCD is a rhombus. Why is this a rhombus? Because adjacent sides are equal, as well as the diagonal is bisecting, or bisect the vertex angle. Okay. Right, so let's look at number 4. We are told that ABCD is a square. We must prove that A1 is equal to A2. B1 is equal to B2, but that we know already. Because those are one of the properties of a square, is that the diagonals bisects the vertex angle. So let's say we are oblivious of that fact. How can we prove that angle A is equal to angle A1 is equal to A2? We can prove that by going with the factor that if that was x, okay, then this angle here would be x, because the angles opposite equal sides. Okay, so since that is a square, we know that is parallel, so that's x. So there we have proven that. So we're going to say, firstly, let A1 equal x. If A1 is equal to x, then angle C1 is equal to x. Why? So angles opposite equal sides. And the fact that all sides equal in a square. Okay. Then we're saying that A2 is equal to x. Why is A2 equal to x? Because the fact that it's alternate angles, with AB being parallel to DC. Now where does this parallel lines come from? It comes from the fact that in a square, two pairs of opposite sides parallel. Okay, so therefore A1 is equal to A2, which is equal to x. Now of course C2 would also be x. So we say C2 is also x. Why? So alternate angles with AD being parallel to BC. Now I've already said two pairs of opposite sides are parallel, so we don't have to state it again. Which therefore C1 is equal to C2, which is equal to x. Okay? And then you can go through the same notion to calculate B1, B2. D1 and D2. Okay. Let's go to number 5. In number 5, we are told that these lengths are equal. Angle DOE is 90. Prove that all the sides are equal. Okay, I can go with congruency here. Okay, so in triangle TEP, is that the P? F, and triangle, so DEF, DGF. No, it's not going to work. So we say in triangle DEO and triangle FEO. I'm going to prove congruency here. Okay, so you got that DO is equal to OF. Why? It's given. Then we got the OE, which is a common side. Okay. Then we can say that DOE is equal to EOF, is equal to 90. Why? Angles on a straight line is 90 there. So what do we see? We have side angle sine. So therefore, DEO is congruent to triangle FEO. Why? Because there is side angle sine. Okay, so from here we can see that DE is equal to FE. So now we have proven this part. That's equal to that. Now we go through the same notion, we can prove that there. The same, you can prove it. So in conclusion, therefore all sides are equal. Okay. Then the second part of the sum says, so now remember all the sides are equal, no? Now we are told that if D1 is x and equal to E2, which is x, prove that angle E is 90. Okay? So here's an x. That will be x. This will be x. Why? Because they're all congruent triangles. At this point we prove all is congruent. So x plus 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 x adds up to 360. 360 divided by 8 is 45. It's 45. So therefore E1 and E2, the combination thereof, is going to be 90 degrees. Okay. In question 6, I don't want to make another video now. Let me just pause this quickly. Okay, so in number 6, we are told that these PQ is parallel to QSR and PS is parallel to QR. Then we are told that PQ is equal to QR is equal to SR, which is equal to. You are required to prove. I'm going to use other kind. I'm not going to do the sum. I'm just going to lead you through it. We are told that you're required to prove that OP is equal to OR. Okay. So all these lengths are being equal, so that angle and that angle the same, which makes that angle and that angle the same. alternate, and then you go with that the fact there. So you're going to use side, angled side to prove congruency, so you'll be able to prove that thing. As well as SO going this way. Okay. Then diagonals bisected right angles. If those angles are all equal, since it's similar, not similar, but congruent triangles, O1 is equal to O4. Why? So the two triangles are congruent. So if the angles are the same and the two angles are on the straight line, they had to be 90 degrees each. Okay.